Hey everyone. Last night I decided to share something I've been working on. I actually shared it previously on a couple of social media, Facebook groups and whatnot. I don't think I actually posted it to my channel just because I wasn't really sure whether I was going to go with it or not, or where it would go to. So anyway, I posted on my Instagram story. Here's just a little snippet, basically showing an MAD, a Mandibular Advancement Device, that I designed digitally to be fully 3D printed. I say fully, and I'll get to that in a minute. There's a couple of little pieces that you do still have to buy, but that's kind of should be expected if you're familiar with this workflow. So anyway, or I should say not this workflow, that's what I'm presenting the video on, but more the device itself, an EMA type appliance. So anyway, without further ado, I'm going to go ahead and I'm going to get into this. Now, a couple disclaimers. Let me bring this up. I actually wrote some out. I don't think I've ever done that in a video before, but I want to do that for this because they're pretty important. So first of all, I am not providing any medical or dental advice, treatment advice in this video. I'm just trying to show you how to do things in the digital world. What you do with your patients is between you and that patient and using your own medical judgment. I'm just trying to give you some ideas of how you might implement those ideas or bring those ideas to life in a digital world. Patients should be screened for sleep apnea prior to MAD usage. I feel that very strongly. You really need to be, this isn't just, it's a snore appliance, a snore guard, whatever you want to call it, but you should be getting down to the, what's the cause, what's the root cause. And this could be an appliance that could help with the cause, but it shouldn't be just an obvious, or, oh yeah, we'll just give you this and everything's gonna be better. Because as the next point goes into, all orthodontic, occlusal, and airway implications need to be assessed before MAD usage. The reality is, an MAD can make these conditions worse or at least unearth an existing condition that you're not even aware of. So it's very important, it's critical that you don't just give these away to patients and without really kind of figuring out what's going to happen. Yes, maybe this takes away their snoring, but is it going to cause other issues? Are their teeth not going to line up anymore? And there's many schools of thought as to what happens when some of these devices are used, but that's not an uncommon thing, that occlusal relationship, where our teeth fit together, no longer are the same. And so is that because you're creating a problem, an orthodontic change that is now like, oh shoot, or are you actually unraveling an issue, an overcompressed joint, TMJs, where you're now allowing the joints to relax and they just don't want to go back to that overcompressed position? Hard to say, and I'm not really here to present philosophy to get over that. I just want to make sure before you go into this, I don't want you to get burned. I don't want you or your patient to be burned. I don't want this to be something that you just go in willy-nilly and not know the possible implications. So again, I think it's these types of devices can present great benefit to patients, but they are not, they're not a simple thing. We're not treating sensitivity where if it doesn't work, oh well, you haven't done any harm, applying some sort of desensitizing agent. This is a much more significant type of treatment. So anyway, that's the main thing there. Also, I haven't done this on a bunch of patients. I mean, I have one of these appliances in the mouth. I have one other printed and ready for delivery. Would have delivered it this week. Unfortunately, my wife came down with COVID, so I wasn't able to do that. And then I have another one that I've just designed for insertion in another patient. So I mean, that's three designs. Each one has been slightly different based on what I've learned as I've gone through this. I think I've settled on, through those trials. I mean, I'll probably make some other revisions over time, but I'm pretty confident in where I've gotten to with this. So understand that this is a starting point, give you an idea of what you can do with software and whatnot, and let you kind of run with it from there. And so I don't know if these are going to break. I'm pretty confident they're not. I've designed them in such a manner that I'm pretty confident, and there's ways to make simple adjustments in the design workflow to account for it if we need more rigidity. But I'm not really worried about that, but at the same time, who knows? And I don't want you to be angry with me if that happens. So that's a disclaimer. By the way, any of the softwares I'm going to tell you, and basically there's one software and some devices you may have to buy. I don't have any stake in you buying them. The software I'm going to recommend is a friend of mine that designed it, but beyond that, I mean, other than goodwill, I don't have any stake in that. There are some devices that I'm going to share with you that I do, that I have designed myself, and they have small fees, $5, $10, whatever, or 10, 15, whatever it is. By the time you see this, maybe the prices go up, I don't know, inflation as it is. So, but reality is, I'll be very clear it'll be very clear when it's something that I have a financial stake in. Okay, apologize for that. I had to take a quick phone call. But yeah, so with all that said, let's go ahead and jump right into this workflow. So a couple things I'm going to point out first is what all do you need to download and ahead of time? Like what software do you need and whatnot? So in my workflow, we're going to need a few different things. I'll talk about first MeshMixer. MeshMixer is the software I'm going to be using for a majority of this. You can probably do some of this in other software, but I think you'll come to see why it's valuable not to do so and why it's best to go ahead and use MeshMixer. So this website used to be down, meshmixer.com/download. They took it down for a while. It's apparently back up as of today. Yeah, then you can just download it right here. I use an older version than this, but I don't believe for what we're going to do it's going to matter at all. So yeah, this is free download. So go ahead and get this, make sure you have this. And also, we're going to need D3 Splint. Now, D3 Splint is the Splint design software that I use. I have lots of videos on it. I'm quite certain that you could do this with Exocad Splint Designer. You could use 3Shapes. You could use Saronis InLab. Most Splint design software is going to be capable of doing what I'm going to do. I'm not doing any sort of sophisticated design. I'm going to be doing a shell and a flat plane appliance. You could technically do this in MeshMixer. Kind of, not completely, but you could do a lot of it. So yeah, but this is the one I use. This one I recommend. I think it works great. The reality is, one or two of these devices designed in Office is going to pay for the software. If you bought an EMA type appliance, they're usually a few $100s. So maybe you can get them cheaper some places, but reality is you're going to be, in a couple of these designs, you're going to have paid for it. So that, you're going to need EMA straps. So these are the little straps that you can buy various lengths, and there's also various tensions, if you will, different colors and different lengths. And I'm not an expert in this area. You can find more videos online to kind of give you more information on it, but reality is we're looking for a certain length. This particular one is 20 millimeters. If I go back a page, I'm in Great Lakes Ortho, or Great Lakes Tech, whatever. Let me see, that's what it was. I just searched EMA straps, EMA strap, and you can see them all kind of popping up. So let me just finish the search and see if, well, anyway, you can find the different lengths, different tensions and whatnot. So that's where I looked at a lot of different places. You can even get them on Amazon, but $25 for $34, that's going to be the cheapest I found by a good margin. It's less than $2 a piece, about $1.50 or so, whereas most places it's $2.50 to $3 a piece. So yeah, Great Lakes Ortho is where I would probably go ahead and order these from. Okay. So, I'm sorry, I guess it's Great Lakes Dental Technologies. It used to be Great Lakes Ortho. And yeah, that's about it. So you're going to need MeshMixer, D3 Splint, and EMA straps. So anyway, yeah, I apologize. I forgot to mention one other thing. I'm having a little bit of sound issues, so I'm using my laptop microphone for this. So I apologize if the sound's not good. I tried to check it ahead of time, but yeah. Okay, so that's it for outside of my website, which you're going to need MeshMixer D3 tool and D3 Splint and the EMA straps. On my website, if you go to barongroderdds.com and go under shop and look up BG Designs. So there's lots of different things that I have links to, like Amazon links and whatnot for different things you can buy. This is specifically things that I've created. And maybe I'll move this up to the top just so that it's easier to find it, because people end up messaging me trying to find this. But anyway, so BG Designs. And there's a lot of different things that I have designed and I share here and whatnot. And you can take a look at some point if you'd like. But for this video, we're just going to come over here and I'm going to try to create more categories over here to further classify things. But Mandibular Advancement Device, or MAD. So these are the two things you're going to need. Now, you don't have to buy these. You could design these yourself, and you could use some other software for this. This is just what I have found, and I have Exocad, I have D3 Splint, I have a lot of different softwares, but for what I'm talking about, these just work the best. And so this is just MeshMixer. It's literally a virtual articulator that I created. It's nothing fancy, but it allows us to do, well, what I need to do. So, and then these are the actual anchors we're going to attach to our appliance. So, $15 for the set, and hopefully that's not too unreasonable. Okay, so once you have accounted for your softwares, your straps, your anchors, and one more software, I think this isn't really a software, but whatever. Yeah, we're good to get going. So I'm going to jump into software now, and I'm going to try to make sure that I have chapters in this video so that you can zip forward as needed to the relevant section. Probably should have started off with that. Oh well. Okay. So let's get into it. Let's see, where do we want to start? So I have created a series of folders. Now, oh boy, my resolution is going to be a little funky. When I record videos, I have to change my resolution so that it comes through 1080p without being all funky. And just trying to get all of these little folders popping up effectively. So, yeah. All right, so in this folder, I just have an upper and a lower. For this example, I've just got a patient's upper model and their lower model. And then once you have downloaded the anchors, you're gonna see that you've got the primary anchor, that you've got the secondary, which is, they're set at different distances, from 14 to 16 to 18 to 20 millimeters apart. And you'll see kind of why that works, or how that works. And lastly, this is the actual semi-adjustable articulator that we're going to use. So how you want to start this is up to you. I'm going to go ahead and open this up first. This is a mix and a .mix file, which is basically a MeshMixer file, and it has a bunch of different components already in there, and we can add to it at our leisure. So let's go ahead and just double click on this. Once you've installed it, you should be able to just double click on it, and it will open up MeshMixer. All right, so let's expand this. And so in here, we've got a number of different things. I'm gonna try to explain it a little bit. First, we've got the arch outline, which is basically just a transparency that allows you to place your models and kind of get it arranged anterior, posterior, and kind of orient things a bit. Incisal pin, this gives us an opportunity to kind of see how much we're opening or closing the bite. And then this incisal plane is a little pin that just kind of sets across here, a little plate, and allows us to see where we are, how much we've opened, 2, 3, 4 millimeters or whatnot. So that's that. What you can't see is what you can't see listed are these 3 pivots, and that's what's been critical to this, is what allows us this setup to function as a virtual articulator. And if I turn on this, I can actually see those listed. You've got the jaw hinge. Oh, that's interesting. This should be right condyle and left condyle. I'm not sure why that didn't save as the correct name. I'm going to change it just so, I don't know, for this video, but it's not going to save on the actual thing. So when you download it, I apologize. Someday maybe I'll get around to changing that. Probably not. But anyway, so these are the different hinge axes. Really, for this video, the only one we're going to need much is the jaw hinge, and I'll explain that in a little bit. Okay, so just a second. Okay, so now what we'll do is we will bring in our actual arch files, the upper and lower. Okay, sorry again about that pause. So now we're going to go ahead and bring in the upper and lower models. Click and bring both of these in, and I'm going to just drag and drop them right in here. Okay, I'm going to click on the append button, not replace or cancel. If you get a little warning that says something about it not being the right size or right location, just ignore that. And so here they are. Okay, not lined up yet, that's fine. Now let me talk a little bit about what we're seeing here. I'm going to turn everything off so it's invisible except the models. Okay, so one of the things is this bite was taken in occlusion. It's not perfect. It's not perfect. It's probably close enough for what we're doing here with splint material. It's going to be more of a flex, a little more giving, a little more forgiving. But I have initially tried to scan people in the position I wanted to put them in, meaning open and protruded forward. And I think that's a bit of a disaster, because trying to get someone in that position with and then scanning them is tricky. I can take an open bite the same way I do occlusal guards, which isn't a terrible idea because I usually do that in more CR, and that's a repeatable position. So that's not a bad idea. I would either do it closed or open on a leaf gauge fully posterior. Trying to get them to slide forward and scanning that's where it's a disaster. And I mean, if you could skip this first step of using my little articulator here. But again, I've tried it and it's just a royal pain. So it's probably best to go ahead and do it in the open relationship you want them in. But that can be a little bit tricky, as you'll see in just a minute. So in this case, I went ahead and did it with the patient's mouth closed, and we're gonna go from there. Okay, so let's go ahead and turn on the incisal plane, or not the plane, sorry, the arch outline, because we need to move these models to line up with that, okay? So first thing I'm gonna do is I'm going to hold the shift button and click on both of these, and I'm going to hit the T button or click over here on transform, and that allows me to rotate. And I'm gonna grab here to rotate it, and I'm gonna click onto these little rotation points because I can go right to 90 degrees. Because it's going to be pretty close to 90. And then I'm going to slide it back. And you can see when the central incisors sort of line up with this. And it's not going to be perfect. That's okay. So I'm going to, and what I want to do first is I want to make sure that anterior posteriorly it's lined up. So, rotation wise. So I'm going to center that, the midlines. Really not imperative that it be perfect. But now you notice that the posteriorly, it's over here and over there, which means I need to rotate this. And since it's going to rotate at the middle here, I'm going to do it about halfway. I'm not trying to make it perfect, so that way, when I now go forward and look at the incisal edges right here and slide it over, now I'm centered again, and now let's look. Yeah, we're still a little bit off. Maybe I went the wrong direction, it's hard to say. Okay, and you don't have to be perfect here, but it is good to get pretty well centered just because we're assuming a symmetric arch, whatnot, and as we estimate the protrusive movement, it's good to have it centered. So there we go, I'm centered now. I can hit accept, and now honestly, this little arch outline is no longer relevant. So we can turn it off so it's not affecting our visual. Now the incisal pin is arguable about how important it is, because truth be told, we're not going to say, okay, we're going to open everyone at 3 millimeters, because that doesn't work on every patient. So you can see it just for visual reference to know, but I don't think it's really that important. I think that what's more important is that we see the pivot, the condyles, because what we're going to do is we're now going to open this patient's mouth up. And to do that, this is where this articulator works pretty well. That's why I'm kind of, I'm pleased with the way it works. So I can take this jaw and I can swing it away. If I hit the T button again, the transform button, I don't want to rotate right here because that's kind of dumb. I don't want to go up and down because that's not how we bite. But while I'm in the transform functionality, if I click up here on this pivot, well, let's hit escape. Click, that's why, because I had actually moved it a little bit. Let's click transform again, and now click on the pivot. Now I can rotate it about this. Now be aware, we don't want the world dimensions of the W, we want the local coordinates. So if we click here, and now you can see it aligns with this, which means I can open and close the mouth. So now it's a little more like an articulator, and I can also open it and I can protrude. Okay, so that's kind of important, right? Now this is why opening just saying that we're going to open at 3 millimeters isn't always accurate if you're not doing it in the correct position. Because if I click on here and I click on right up here, I'm going to hold the control button and click incisal plane. That selects these two things. So now when I hit transform and go to rotate this, that little plane moves with me, which allows me to kind of measure over here and say, oh, well, I've opened it 5 millimeters. That's a lot. Well, now I need to slide forward. And that's a lot more. Okay? So even if I was at, say, let's go to 3 millimeters, and it can be a little tricky because we're working a ways away. I need to, oh, here's a little trick. Go into View, change to, oh, I can't see it because I'm in the, down here is, there's a, there it is, orthographic view. Now, it's hard to describe what that means, but I can look at everything straight from the side. I can click right here on the left. And now I can watch and say, okay, well, let's open just, it's really touchy. So right now we're at 0, and let's go to, here, and that's 1, that's 5. See, there we go, I'm at 3 millimeters. Now as I slide the jaw forward, that's still a bit much. If I'm going for incisal edge to incisal edge, which is pretty common, that might be a bit much. I mean, maybe that's good because it's going to give me, what I want is I want to have a shell that's 1 1/4, 1.5 millimeters thick, and a 1.5, 1 1/4 on the bottom as well. That looks like more than, that's about, I can see right here, 3.5 millimeters or so of distance. So yeah, that's a bit much. So again, I'm not trying to overcomplicate this. I'm just trying to show you what is possible here. So I'm going to hit the escape button, and now I'm going to go ahead and I'm just going to select these again. So when you're actually functioning, when you're actually doing this, sorry, I didn't mean to select everything. Incisal plane, and now hit transform, click over here. And so what I'm going to try to do is I'm going to try to open it about 2 millimeters. Good grief. Somehow I accidentally selected the, I keep doing that by holding the shift button instead of the control button. Don't press the shift button, it gets everything. Now click here, open this up, make sure we're on local, and let's open this up about 2 millimeters. Yeah, we're there already. Now let's slide forward edge to edge. Looks pretty edge to edge to me. Yeah, let's go with 2.5 millimeters. Let's slide forward, edge to edge, and that should hopefully be enough space. Okay? This isn't exact science, but it never is when you're doing this kind of stuff. So here we go. So now we've got these positioned where we want them. We can hit accept. So if you want, you can go ahead and save your work. I don't usually, but because I'm making a video, it would really stink to have to have an issue. Oops. Well, that's fine. I accidentally saved over my Articulator mix. Didn't mean to do that, but that's all right. It should be, if you ever do that, you can always get it back from your, you'll want to undo that. Okay, so now let's go ahead and export these models, because now we have the correct relationship that we're going to make this appliance out of. So let's go out to export. And I'm doing this test, and let's just say this is the upper 2. This is the export lower 2. Okay, now we can go into D3 Splint. So D3 Splint, there's my software. It's going to open up. And so the first thing I need to do, now if you've watched my Splint videos before, you're going to be pretty familiar with this workflow. The first thing I'm going to do is click on not for clinical use. All this means is that you're accepting responsibility. The software, you're approving it. Software isn't guaranteeing any clinical acceptable results. It's like making something in your lab. You are making that determination. We're going to design two different appliances. On the upper, it's going to be a simple shell, basically kind of like a suck down, and on the lower, it's going to be a flat plane. Now that's my preference. You can do both shells if you want, but I think you'll see in this video why I prefer to do the flat plane. So first we're going to do maxilla, and we're going to click simple shell. Let's go ahead and grab our files. We're in here, we're looking for the 2. Now this weird thing about Blender is you are supposed to hold shift as opposed to control. I don't know why they flip-flop that in Blender, always kind of driven me nuts, but click import, and here are our files. Use the wheel button to tip things around. Hold this shift button and the wheel button to move things this way. Okay, now we're going to click set splint model, and we're going to click on this guy. It's going to ask us to set opposing, this guy. And now I'm going to go ahead and set the landmarks. Click on this, and what it's doing is the software is now getting to find out where is this arch. Now this is an interesting one because they've got a pontic here that's basically taking the place of the molar, but that cusp is about the same spot as what I would want. I'm going to click on the incisal ledge, and this is telling us where to click. Now we're going to go right in the midline. Click finish. And now I'm going to go ahead and click on survey model. To do this, all we're trying to do is create a good path of insertion so that the undercuts are sort of uniform. I'm going to minimize this menu or instructions, and I'm just going to kind of look, and I'm going to say capture view. I can tweak everything as much as I want, but I can tell you that's about what I want because I know I'm going to have undercuts back here. This isn't the best model. I'd rather it actually wrap around the teeth here, but whatever. You'll see that it shouldn't really matter too much. Now I'm going to click commit, and I'm going to save. It tells me I need to save. Let's go ahead and save. So we are in here. I'm just going to leave this as John Doe MAD. Enter, enter. Okay. Now I'm going to create a refractory model, which is basically a model with the undercuts taken out. And we get to determine how much we want. You know, everyone's going to have different preferences here. I'm kind of going back and forth, you know, trying to get it just right. And right now I've settled for now at an undercut of 0.11 and an offset of 0.06. So the offset is the gap. The undercut is how much it bites into the undercut to keep retention. Click OK. And so now it's going to create a little green model where you can see everything's been blocked out. Okay? So now I'm going to mark the splint outline. You can design this however you want. I've been kind of tinkering around with different designs, and what I'm going to do right here is I'm going to create more of a scalloped design. I'm not going to spend a whole lot of time on this because it's just not relevant for this video. And I'm just going to come right back here, sort of straight on the posterior. I'm actually on the refractory model there, everywhere actually. It just allows you to see the teeth. And then staying pretty much just right equigingival at the mid cervical areas everywhere else. Now because we did have some missing scan data, we're going to see where we have to massage it a little bit. You'll see what I mean in a moment. Right here where it's having some issues. But we'll come back to that in a minute. Sometimes the software can fix it on its own. Usually, in my experience with occlusal guards, I don't usually have that issue. Notice how this is way up here. Okay. And again, this video isn't about how to design the shape of it. You do what you want to do. I'm just kind of toying around, seeing if patients like certain designs a little better, more comfortable, more aesthetic, or whatnot. And when you get towards the end, just hover until you see the lines kind of connect, and there you go. Now you can grab and move nodes however you want. Now what you need to do is you need to look for any issues where it's red like this, or like that. If you want, you can click show problems, and it puts little beads anywhere there are little red dots saying, hey, by the way, this isn't going to work. We need something. So you add a node there. That's fine. And this one might be even more tricky. We'll see. I don't usually have these issues, but I noticed that when I was kind of testing this out that I didn't like it. There you go. That orange line shouldn't cause an issue, but we'll just see. Yep, it still doesn't like it. Show problems. and it's this missing data. So I might be able, I can right click on nodes to get rid of them. Actually, that may have fixed it in and of itself. It did. I just had too many points. I was going to try to drag it up onto this model area where it's a little bit more known data to the software, but yeah, I'm not seeing any problems. Again, honestly, until recently, I didn't even know that it was here because I never had that issue. But let's click next. Now it's got this little eyedropper. We're going to click on the inside, and that way it knows this is the data we want, everything else is outside the arch. Click next, and it just makes a nice smooth line. All right, click next. And now we're going to keep scrolling down. We're going to click Splint Shell. We're going to design our thickness. I've been going with just a 1.2 because we're going to be splint to splint, so we don't need it quite as thick. And click OK. If you want it thicker or thinner, by all means, have at it. And you know, this is a little bit closer than these teeth than I would have liked. That's okay, not a big deal, but yeah, we'll see. We'll see how that works out. And we don't need to do minimum thickness. We're just going to go ahead and we can finalize right here. Now, I'm going to go add one more little caveat here. You don't have to do this, but I'm going to show you how to smooth this up even more. And to do so, we need to change the style, because I don't know why, but it hides some options for us when we're in simple shell. So I'm just going to click into anything, flat plane appliance. Now it opens up some other little options right here where we can auto sculpt some concavities, so little indents here and whatnot. It should fill some of those in, maybe not perfectly, but it will help us a little bit. And then I'm also going to block out large concavities, and you see how that kind of smooths that out. And I like to go one more time, just click Remesh Smooth, just to fill it out one more time. There are sculpt tools where you can even further smooth this, but I don't really think it's relevant or necessary, but that's something you can do if you want. But now I'm done. I could change it back, but I don't really care. I'm just going to scroll down until I get to this finalized splint, because that's all I need to do. I'm not adding a raft. Do not bother with that. I'm a big fan of that on splints. This is not a situation where we're talking about just a simple splint. So now you can see this is going to fit on the teeth quite well. Okay? So we're halfway done, and the next part is going to be pretty simple. A couple more steps, but hopefully faster because we've already gone through these initial steps. So if you keep, I'm going to hide this because I don't need to see this model operations or model text embossing. We want to go to plan opposing splint. Click there. Just go ahead and say OK. And so now if I scroll to the top, it's now going to be a mandibular, and it keeps the same design that was there. It happens to be flat plane because that's what I previously done, which is fine. That's actually pretty helpful. Go ahead and check this box for auto background. I'm not going to, because for the video I want you to see one step in particular that is helpful, that I want you to understand. And if I check this, you won't see it, so it's going to be hard to explain. So check this, it'll save you some time, but in the video I'm not going to. Now, one big thing is we're not, right now, it thinks that this is the treatment arch and this is the opposing. Nope. We're going to click this even though it's already checked, and I'm going to reset it as this being the opposing. Because I want this lower flat plane splint to be made according to this, as though this was the maxilla. Right? I changed that color because of that. So now I'm going to create the articulator. I don't even know why. Not really necessary. I mean, you don't have to. You can probably skip it. But this is articulator. And this is what I was saying, is that you could open the bite in the software, but getting it to protrude on your, to desired amount is where, honestly, maybe Patrick can come out and show us how to do that, but I don't know how. So that's where I use my little articulator to do that. Okay, so now we're, again, that wasn't really necessary. We're going to click on Survey Model, just like we did earlier. It's kind of zoomed out, kind of hard to see. Let's bring it down. Let's hide this because I don't need to see this. And we're going to look down, make sure I can see down the incisors. I know I'm going to have some significant undercut back here, but it is what it is. Click Capture View, and now look. I've got a little bit there, a lot of it back there, but not really much I can do to fix that. So I'm going to go ahead and accept it. I can always, again, I can tweak it different directions if I want. I'll click Commit. It's already been saved once, so it doesn't, you don't actually have to. It won't force you to. I'm going to because, we've just done more work, so we should just go ahead and save it. Click on refractory model. It's going to make that green model with all those undercuts finished. We got to determine what our parameters are for that. I think I was, none of that. All right. Okay, so here's that. Now we need to mark our splint outline. These teeth are pretty short, especially in the posterior, so I'm going to show you how I would approach that. And with a flat plane, I don't like it to be, well, especially on the lower, too scalloped. I don't see the benefit. We're going to be placing our anchors on these molars, and they're kind of short, so don't be shy. I would get it down a little bit because you're going to want some splint to actually put those on. Probably don't need to be too far in the second molars, but okay. If you notice that you accidentally fall off, that's because I was here and moved it, so it didn't know to continue. So I'm just going to I right-clicked it to make that disappear. Click on this one again so it knows, pick up where you left off. And this video might not make a perfect design because I'm not really, I'm just doing a video. So I probably will skip some, nuance, if you will, to making it just the perfect fit for the patient. This is not going to go in a patient's mouth. This is just a video. So I'm going to try and, so notice that since I moved it, that's the highlighted one. I need to re-click on this so it knows that I need to pick up where I left off. And once again, I'm going to be putting an anchor outside of this too, so let's make sure we've got enough of a splint to have room to do that. And then when I'm done, kind of hover by it where this line pops up, and there we go. So let's see, are there any problems? Show problem. Oh, there is, one way back there. I kind of saw that coming earlier. So let's just click on this red dot, see if that fixes it. Nope, it didn't. Okay, let's show problems. Looks like we're pretty good. Okay, let's go ahead and click next. If you don't see an eyedropper, if it's still like a crosshair where it wants you to put points, that means you've got an error. So you gotta find more errors. Just click on this. The inside side should be highlighted. Click next. It's kind of jaggedy along the edges. Now it's nice and smooth. And say next. Okay. Again, adding that articulator was kind of probably dumb because all it does is get in my visual way. And we're gonna click splint shell. Once again, I'm gonna dial this down here. When I do a single arch, I usually dial it up to 1.75, but again, we're gonna be splint to splint. I don't think you need that thick. Click OK. And now it's gonna make that shell. And good, I'm happy because we have some gap. I don't have to, but I would like to, because that means we're gonna have at least 1.5 millimeters of thickness everywhere. And since I don't see any overlap, I don't need this minimal thickness. This minimal thickness is like, okay, I want it to be 1.5, but I want to make sure it's at least 1 millimeter. This gives you a chance to kind of confirm that. But I can see air between everything, so I've got plenty of space. Click Mark Occlusal Curves. Now this is the next step in making a flat plane appliance. If you've watched my videos before, you'll kind of know what to expect here. Now I've kind of continue to always make sort of adjustments to how I do this, and fewer lines, just the more rounded it gets. Now we're going to do the mandibular line. Come here to the most lingual portion of these anterior teeth to here. Now because these teeth kind of will go wonky, I'm going to click here and then maybe here and here. Okay, click commit. And so now when I click on splint wax rim, it's going to create a rim that is those dimensions wide. It interferes with this, that's fine, we don't care. We're gonna fix that in a minute. First we need to fuse the two of them. Notice we're just going through the checklist all the way down. Okay, so now we have a splint, without the occlusal. I mean, it's invading the lower teeth, invading the upper teeth, but it's also got these like indents and stuff, and I'd like to kind of smooth that out. You do have some sculpt tools where you can really get to it, and you've got all these different tools here. I try to avoid as much as possible because honestly I'm just not great with them. But when you finish it, just click finish that. Instead, I'm gonna stick with these. I'm gonna auto sculpt this. I know I'm kind of going reverse order. I've been playing with this a little bit, trying to get it just right. I'm going to click on block out large concavities and just try to get the software to kind of smooth things for me. That's looking good, looking pretty good. Now I'm going to click Remesh Smooth one more time. When you click block out large concavities, it blocks them out and then smooths it. But I like to smooth it one more time, just so everything sort of blends in nice and smoothly. And by the time you're done printing, it's all pretty smooth. You could use your sculpt tools to fill in these little ledge here. I don't see the necessity to do that, but that's where you could do that. In particular, just so you know, I click on here and I would use the inflate. And then you could kind of run through it, inflate it all, and then use that refresh smooth a few more times and remesh smooth, and it will kind of smooth it out. But anyway, now we have to figure out how to flatten off this top. So we're gonna click on posterior contacts, and I literally mark every single cusp tip and every single and the incisal ledges of each tooth. I think it's important. You might disagree, and that's fine. You'll be wrong, I'll be right. No, I'm just playing. But the point is, we want, wherever I mark a point, that's almost like saying that point is going to contact the opposing arch, or at least be pretty close. That's sort of the goal, right? We want a flat plane where everything's sort of supported. We're not, dictating new occlusion. So you can kind of drag it to where, if you see like a large area, just kind of drag it to the middle of it or so, try to find the highest point, and sometimes it just shifts. That's all right, whatever. And yeah, you can kind of tinker around with this all you want, but it's not that critical that it be perfect. But yeah, so you got kind of all this universal occlusion, if you will, where it's all going to sort of settle. And so now I click next, and so this is like a blade. This is our flat plane. It's not flat, but it's flat relative to the arch. Okay, so now I can say commit, and right down here it says subtract posterior plane. So I hit that, and now look what happens to our appliance. You see that it's all been subtracted. Where it was invading our upper arch, now it's not. It's just touching, just barely, but not much. Here's the part that automatically happens. There's a few different things that automatically happen, actually. Our splint shell thickness, we would have had to change that, so we would have been smaller if we did this auto background, so it wasn't 1.5 millimeters. But if I click auto background now, what's going to happen is, I didn't mean to do that. Let's undo that. This step right here is one of the things that happen in the background. So let me get in a good visual spot, because I want you to see what's happening. Click OK. And so here's the functional surface. This is the patient going into excursive movements, into protrusive movements, all throughout the range. And it's not like every single possible step, but it's a lot of different steps. And so what we're going to do is we're creating a plane of what those movements are, so that we can then subtract it from our appliance. So that what it does is it gives that patient the ability to move, to protrude, to slide left and right, which is important because with a MAD appliance, we might have to titrate them farther forward, farther backward. And by doing this, we've created that flat plane, but we've also said, hey, but if we have to shift it a couple millimeters here or there, we're not completely locked into this position. I said earlier, you could have just done a simple shell and just called it a day and move forward, which is fine. That's what most of these EMA appliances look like. But we have the opportunity to go ahead and add this flat plane. I feel like that's just a better occlusal situation and more for titrating the appliance, forward, backward, left, not really left or right, but that's my thinking. That's my theory for now. Okay, grinding MIP is more important for actual flat plane appliances, but let's just go ahead and click this, and what you'll see is it grinds out these little spots where there's contact. Well, yeah, these little dots. These are sliding spots, but yeah, I mean, it's not the worst thing in the world, but, and what I like to do is I like to hit Remesh Smooth to give me it nice and smooth one more time, and then grind MIP one last time. So that's it. I'm done with design, with the two appliances that make this big appliance together. Oh, what we haven't done yet is if I were to, well, you can see just by looking underneath, the underside is still not finished. That's simple. All we do is come down here and click Finalize Splint. and that's going to cut out the refractory model, that undercut model, from it. And so now we know that we can insert this into the patient's mouth. Okay? So now if we go ahead and I can turn on the opposing splint right here, and I can say that, okay, well, these two are the things that I want to keep. Okay? So we need to export both of these. There's lots of ways to do it, but I'm going to go ahead and let's see. I'm going to do something while making the video that I probably shouldn't be doing. Select. That's not what I'm looking for. Mesh. No. Okay. So what I want is I want the final splint, and yeah, I held the shift button, and now these are both highlighted. So now I can come up here, hit File, Export, STL. Want to make sure we have selection only, and we're going to go ahead and yeah, just go ahead and hit Export here. Now, I could be wrong. I may have to do these one at a time. Apologize. There's plenty of ways to do it, but I've been kind of tinkering around with this. Let's just look at this. Notice the file size is ginormous. Printing makes printing a little more annoying, but yeah, here we go. So we've got our two different things. It's one STL for now, but we can separate those later. So at this point, we are done in D3 Splint. I'm going to go ahead and save it because, well, again, like I said before, kind of dumb not to. If you ever want to make a change, you want to change the tightness, you can do that. And I've got other videos that kind of show how to do that. But suffice to say, you delete the final splint, you make a new refractory model, and then finalize the splint again. And then you've changed the fit. Okay. Open. We're just going to open up this original one. If I had exported the models with it, well, they still wouldn't have been aligned with the articulator, but it doesn't matter. I don't need the articulator anymore. I'm done with the articulator. So now I've got these two different things. These are both kind of this light gray because they're both the same. They're combined right now. To fix that, I can come over to the select button or press the S button on your keyboard. I can just double click on one of them, pause, hold your mouse still while you do this. Now hit the Y button. I think it's right here, separate. And so now I've got two different things. There's the upper, there's the lower. If you want, you can go ahead and even say lower, just to help you as you're kind of looking at things for this next step. Upper. Okay. So now what we need to do is we're going to attach our little, let me show you. We're going to be attaching these guys, but like I showed in this video, these two anchor points. And these are sized to attach the EMA strap where it can be removed and replaced because, titrating it, but also hopefully retain it well long term. Okay, so what we need to do is we need to find our anchors, and when you download it, it's a zip file, but it's got these in here. And what we want to do is we actually want to bring all of them in at once. Okay, well, we can do one at a time or not. But what we're going to do is we're going to drag and drop them here, hit append, ignore this, hit no, 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 no. Okay. And so here they all are over here. We've got this primary and each of the secondaries. I'm going to hold, in this case, I am going to hold the shift button because it's going to select everything between the top and bottom one. And I'm going to start moving these as I wish. So once again, hit the transform button, and let's just get these over here, kind of in play, if you will. Let's rotate. Let's change to local coordinates, not world, so I can move these, relative to their own setup. And I'm trying to get it on the canine. It's going to be canine and molar typically, but if I can position this one first, And now I can just sort of, okay, let's look at the, it's maybe inside a little too much. We're going to deal with that. It's going to be, I made these specifically long enough to kind of intersect within the arch. That's fine, within the tray. So now we can rotate it until it's down on the molar, one of them. Again, there's 4 different ones here, but I do that because now I can pick whichever one's centered. In this case, it's the farthest one out, which is the 20. If I want to use one of these, that's fine. I want to use a shorter strap, but I mean, I can't necessarily, so I'm going to have it right here. But that's okay because I can have it wherever I want. It doesn't have to be outside the molar. You can have it wherever you want. So if you want to have it, a different one, you want to use a 16, then you're going to have it down here. You get what I'm saying? Okay. So, but we made sure there was enough surface area on this molar by bringing that splint line down a ways, and I think we're pretty good here. Okay, sticks through a tiny bit, not a big deal, like I said. And you can adjust the in-out as much as you want, but I'm going to go ahead and click Accept. Now I'm going to hold the Shift button, I'm going to hit the S button. Or sorry, I don't need to do that. I apologize. They're separate objects. I'm going to click on this one, hit Delete. This one, Delete. This one, Delete. I'm good to go. I've got these positioned where I want them. Now they're overlapped right here, and I'm going to show you how to fix that now. Okay, so first of all, let's do the upper with this guy right here, which is the primary. So I can turn off the secondary. I can turn off the lower, and so I've got these 2 surfaces here, and I need to make it so that this is not intruding within here. So I discovered, while working through this, trying to make this as easy as possible, I was trying to figure out little tips and tricks. Now, I wouldn't even mess with this one because it's just not going to interfere. But let's pretend you had to. I'm going to turn these off, and I'm going to create some surfaces, some groups, surface groups on here. It's very fast and easy, and this will help you with other things if you're using MeshMixer. If I click S, I'm going to dial this up a ways so it basically covers the entire model. I'm going to increase this crease angle. So if I press on this right now, it highlights everything. I don't want that. I want to highlight just the bottom and this first ridge. So what I'm going to do is I'm going to drive my crease angle up way up. And what that's going to do is it's only going to collect, once it falls off an angle, it can't select anymore. And I can click there. One click each. Oh, this part, the circle wasn't big enough, so now I've got it. Click. Oh, these are 2 separate objects. Okay, that's fine. So let's go ahead and now let's do it. They have to be combined. Sorry. Well, we don't need to modify this one anyways, so I'm not going to waste time showing you how to do that. It's just not really relevant. I do want to. Sorry, back and forth, because I want to make sure that you know how to do this if you want. Because most of the time you do have to adjust both of them. So let's just combine these right quick. So now they're one STL. Hit Control A. That selects everything. Notice that this is gray and this is peach. I don't know what color it is. We want to make these both gray, so they're base level both together. Hit Control A to select everything. We're going to Control Shift G, which is the same thing as modify, clear face groups. Now they're both gray. So now I can get back to what I was talking about. Large size, large crease angle. Click here, click there, click here, click there. Make sure the bottom sides, they're all selected. And now I can modify by hitting Create Face Group or Control G. So all I did was made them so they both had a surface group here and a surface group there. I want you, now you'll be able to see why I did that. It may seem like, geez, that was a lot of work. It really isn't. I mean, on this video it is because I was tinkering around wasting time, but reality is, all I did is hit select, made it big, made the crease angle big, and selected those 2 areas, hit Control G. I could have done it twice, one for each one. I didn't have to combine them, but I did. So now, if I turn on the lower or the upper, what I'm going to do is I'm going to basically melt this back so it lines up with this. I don't want to screw up everything in here. That's why I made a surface group. I want it to be just, I want it to be, I just want to augment the purple portion. So to do that, I'm going to use the attract tool. It's a magnetic attract tool. So I need to determine what's going to be, am I attracting to? And I'm attracting this. I'm going to suck this up to this splint. So this is the magnet. Okay? If you don't like the way this appears, because it's like hard to see, it's just fine, it annoys me too. You can use this little tool over here to just change the color of the splint. And now when you turn it magnetic, well, some of the colors, I don't remember which one I did earlier, it kept it from doing that. Well, maybe it was a glitch. Anyway, we're gonna melt this back so that it merges with the model. So we have to select this, come into our sculpt tool, and we're gonna go to the attract tool. Now we don't want our size very big. That's, maybe 25, 30, somewhere in there. Now here's one of the things that I've never really used before until I started working on this. Coming down to filters, we want to preserve the groups. I don't want to screw this up. So now I can click and you'll see you're kind of melting it so that it matches right up against this. And hit Control Z, and I'm going to turn up the strength. And I'm going to turn up the size a little bit. There we go. Now let's look from the outside. Let's go ahead and just hit Escape to get out of this tool so we can see how it looks. Turn off this. And we haven't really messed it. It's a little bit rough, but it's not gonna, by the time you print it, you're not gonna notice that at all. Yeah, we left a little bit. Nuts. No big deal. So we just go ahead and turn this back on. Click on the Sculpt tool. Oh, gotta make sure we're selected on this object. Sculpt. There we go. Let's hit Escape. Turn that off. And there you go. Don't worry if it looks kind of funky. That's not going to matter when it's printing. Now it's nice and blended in. You could do that on the lower one if you wanted to look a little bit more merged, but I wouldn't. And I don't see the necessity here. And so now all we need to do, and I'm not going to do the other side because that's just going to take up more time in this video. It's already long enough. So what we would do is I'm going to go ahead and I'm going to separate these two again. That's why it probably was a bad idea to do that. But I need to turn these off. I'm going to hit Y to separate that one out. So that now I can turn off one. So let's just say you had one on both sides. I can click Control, just select those two. And I can click Combine. And I can hit Export. And now MAD upper print ready. I like to use that terminology because whenever I come back, I know that this is the object and go straight to the printer. I never have to think about what it's there for. Now, I want to show one more thing that you could do that I didn't do in this video, but I do think you can get away with. And let's just pretend that the arches, this one worked out quite well, but sometimes I feel the need that I would really wish I could tip it in a little bit. And that this one, well, it's combined. I wanted to tip it down. You can get away with that because these EMA straps are sort of an elasticy material, and realistically, it's not going to cause a problem. It's always being stretched and bent anyways in the mouth, so I don't think it's going to be a big deal if you want to tweak them just a little bit so that now it's not impinging. I don't think it was really relevant how much it impinged, but if that slight adjustment is all you need to do to get it from being in there, I would just do it. We're not talking about perfection here. We're just trying to get it pretty close, and again, twisting that little elastic strap is not going to matter from there to there. Okay? So lastly, just so I can finish this completely for you, I'm just going to show you how I would print this. I'm opening up the Rayware software. You might decide to print it on their dashboard or whatever software you're using. So I'm going to go ahead and find my folder. Here's my upper print ready. I didn't even do the lower, but I didn't export it. No big deal. I think you guys know how to do that. So what I would do is I'd hold the shift button and I'd tip it forward at 45 degrees, and then I would print it like that. And I would hit supports, and however you want to do it. Generate selected, and here's the supports I'd have for this. I'm a big fan of not using supports whenever possible, but with these little anchors, it's really going to be hard to not use supports. They're going to create overhangs that are going to be problematic. Also, if you're wondering why do I tip it back at all, well, it makes this part more vertical and this part also somewhat vertical, as opposed to, it's not that important because we're using supports. You could probably just print it horizontally because it is so off axis. I don't know. It really probably doesn't matter. You get sort of used to your routine, and this will certainly print faster to have it like this, and maybe that's better. I don't have any dog in this particular fight. Since it's enough of an angle, it's probably fine. I don't like printing things on supports completely horizontal. I think it causes too much stress on the printer itself and leads to failures more likely. But lots of people do it without problems, so whatever. But yeah, there we go. I think I've covered just about everything. I sure hope I have. Let me get back and just jump to here. So I'll probably try to find a spot to put this video in the online learning section. I need to create another page, I guess. Basically for probably occlusal guards and for my MAD appliance now. So I'll add that soon when I get around to it. But thanks for watching. I hope this video was helpful. Let me know in the comments. The whole like and subscribe. That way you can see new videos as they get posted, new tutorials, new tips and tricks. And yeah, thank you guys so much for watching. I hope this video was helpful. I'm sorry it's a long video. I don't think, in my experience, I've made these a few times. I've 3 specific ones for specific patients, but I've gone through the practice a few times, at least half a dozen times or so. And at this point, I can do the entire design, we'll say 25 minutes. It takes about 4 or 5 minutes to do the initial bite opening and arch positioning, and then it takes another 7 minutes for that flat plane appliance. The initial shell is about 3 or 4 minutes. So we're getting close to 15 minutes at that point, and then adding the buttons is another 5 to 10 minutes. It can be a little bit picky, so 5 or 10 minutes is pretty safe. I can't imagine this taking any more than 25 minutes. So and that seems to have been the case. And I just made a video in an hour walking you through every step of the way. So if I can make a video in an hour, that usually means that I can get the process done in about a third of the time. Usually, whenever I'm making a pretty lengthy video with lots of instructions, I think this is about a 20 to 25 minute process. So, anyway, thank you guys so much. Look forward to seeing you in the comments. Yeah, have a good day.